Hello, everyone. It is Sunday, the 21st of July, 2024, and I was not planning on doing a video today, but after yesterday's video, I was a VIP guest on Jaren's YouTube, I guess, channel, and I highly encourage people to take a look at that. It was very interesting. It was a question and answers period, so it wasn't anything regarding specifically like flat earth topics or true earth topics or anything like that. It was a free-for-all, and it was actually really fun, and so I would most definitely do it again. But like after talking about magnetism and electricity again, I feel like I need to do a video. It's really hard to explain like my thought process because I don't have a frame of reference for anything that I've looked at, researched, any books I've read, etc. on electricity and magnetism, and these forces interacting with each other in various states and in various forms. And so like even trying to take notes and stuff like that, it's really complicated. So I was on Chat GPT, which again isn't an accurate social media software program, but it does have a lot of useful information that is accurate, that I can lean off of in order to get a better understanding of what's going on in my brain. Because to explain this or to articulate this out loud, it's been challenging, I'm not gonna lie. And when I'm going up against people that like Tesla and Walter Russell and even people like Ken Wheeler, these people are geniuses. It's really it can also be a little bit daunting, I'm not gonna lie, to try to and even Jaren, he's a literal genius. And so I don't like, so I just wanted to leave the magnetism thing and the paramagnetism, the diamagnetism, because I wanted to do a little bit more research so that I can articulate myself more. And so like that's why I was kind of dismissing it or brushing it off yesterday. I didn't want to explain further, but I did do some notes. So I was talking about in my own notes last night, just jotting down like water in different states or modalities, the forces operating with different states. Anyways, there's different forces that operate differently within the different states of matter or the elements. And I think the way that it's being explained to us is incorrect. And but there are ways to find the information. And so I was looking at things like the different elements in the periodic table and the different forces that interact with them to make them either electric or magnetic or both. And if things like density, temperature, and pressure are what impact this cosmos, and we're kind of operating or living on the like in the area where there's equilibrium, which makes it work. We can thrive in this environment, like at the level we're at, or this plane of inertia that we're experiencing life in, humans I'm talking about. And perception is reality. So I do believe that this is some kind of an electromagnetic reality that's being projected via like the visible and non-visible light spectrum, but through our eyes. Perception is reality. That's what I mean by that. And we do have crystals in our eyes, and we do have electrical magnetic components within our eyes and in our brain and in our hearts, in our bodies. And so just like a video game, it's all very interesting to me. But so density, temperature, and pressure do impact not only us, but all the like essentially every single element on Earth that comprises this cosmos. And and electricity and magnetism, like I'd like to say, they interact differently within different states of matter, especially water. And I'll explain further, but I do want to get on Chat GPT. I was on it earlier, and as soon as I logged in, after like I was doing a series of questions, as soon as I went to log in, it completely shut out, unfortunately, my previous conversations. And so I'll try to get back to that. But so like my first question when I logged in and lost all my previous stuff was what gases are diamagnetic, right? Because I look at the periodic table, which also include the gases, that make up this atmosphere, or whatever you want to call it. And so there's people that believe that that oxygen, for example, is diamagnetic when it's possibly paramagnetic, and even hydrogen and helium, when you remove electrons from them, they become more positively charged or more magnetic. And so the higher up you go in elevation, I do believe that we're experiencing more of a magnetic environment, and the lower we go down, like the various densities and temperatures and pressure systems in water, for example, it would be less magnetic, but more electric. And anyway, diamagnetism is a property of materials that causes them to be repelled by a magnetic field. In diamagnetic materials, the orbital motion of electrons creates small magnetic fields that oppose the applied magnetic field. So the orbital motion of electrons creates small magnetic fields that oppose the applied magnetic field. This effect is generally weak compared to the other forms of magnetism, paramagnetism, and ferromagnetism. So there is repelling, there is attracting of various particles. It depends on what state they're operating in, and the temperature and the pressure systems that they're operating in. So I wasn't that great at explaining that yesterday as well, but density, pressure, and temperature absolutely matter with how this cosmos plays out. So several gases exhibit diamagnetism. Common examples include nitrogen, helium, neon, argon, hydrogen, methane, carbon dioxide. These gases have filled electron shells or paired electrons, leading to the cancellation of magnetic moments and resulting in a weak diamagnetic behavior. And so I just put in paramagnetism and ferromagnetism just for an explanation of that. Paramagnetism and ferromagnetism are two other types of magnetic behaviors exhibited by materials. Here's a brief overview of each. Paramagnetism. So paramagnetic materials are attracted by external magnetic fields due to the presence of unpaired electrons that have magnetic moments. Unlike diamagnetic materials, the magnetic moments in paramagnetic materials do not cancel out because they're not all paired. However, in the absence of an external magnetic field, these magnetic moments are randomly oriented due to thermal motion resulting in no net magnetization. Key characteristics of paramagnetic materials: they are weakly attracted to magnetic fields, and examples include aluminum, oxygen, titanium, and certain metal complexes. And so ferromagnetism. Ferromagnetic materials exhibit a much stronger magnetic behavior. In these materials, the magnetic moments of atoms or ions are aligned in a parallel fashion within regions called domains. When exposed to an external magnetic field, these domains align themselves in the direction of the field, resulting in strong magnetization. Key characteristics of ferromagnetic materials: they are strongly attracted to magnetic fields. They can retain magnetization even after the external magnetic field is removed, making them permanent magnets. And examples include iron, cobalt, nickel, and some alloys like steel. In summary, paramagnetic materials have unpaired electrons and are weakly attracted to magnetic fields but do not retain magnetization. Ferromagnetic materials have domains of aligned magnetic moments, are strongly attracted to magnetic fields, and can retain magnetization, making them useful for creating permanent magnets. Oxygen is paramagnetic. So I put that in because people were saying that oxygen is diamagnetic, and I was like, I don't really agree with that completely. So I just put in oxygen is paramagnetic just to see what it would come up with. Yes, oxygen, O2, is indeed paramagnetic. This is due to the presence of two unpaired electrons in the molecular structure. According to molecular orbital theory, the electron configuration of the oxygen molecule shows these unpaired electrons in anti-bonding orbitals. Here's a brief explanation. Molecular orbital theory and oxygen's paramagnetism. In the molecular orbital diagram for O2, electrons fill the bonding and anti-bonding orbitals. The highest occupied molecular orbitals, I don't know why it says it, but there you go, are the anti-bonding orbitals. These are two electrons in these orbitals, and they are unpaired. The presence of these unpaired electrons results in a net magnetic moment, causing O2 to be attracted to a magnetic field, a hallmark of paramagnetic behavior. This property of oxygen can be demonstrated by placing liquid oxygen between the poles of a strong magnet, where it would be attracted and held in place. So I just put in, highest occupied molecular orbitals are antibonding orbitals. Yes, in the case of oxygen molecules, the highest occupied molecular orbitals, HOMOs, are indeed the antibonding orbitals. Here's a more detailed explanation. I just wanted them to break it down more. This is really complex, I understand. So molecular orbital diagram of O2. And so there's different forms of, there's different degrees of energy exuded by oxygen in various states. electron configuration of O2. O2 has a total of 16 electrons, 8 from each oxygen atom. So you've got the 88, the 88. Anyway, these electrons fill the molecular orbitals in the following order. So here you go. Thus, the electron configuration of O2 in its ground state ends with 2 unpaired electrons in the degenerate 2px and pi 2py antibonding orbitals. I don't know how you'd say that. These unpaired electrons give O2 its paramagnetic properties. Conclusion. The presence of these 2 unpaired electrons are the reasons for the paramagnetic nature of the oxygen molecule. So I asked, so there would be an increase in magnetism the higher up in elevation we go, and a decrease in magnetism the lower we go. I'm talking about like in water versus in like higher up in the atmosphere. So this is what they're going to come back with. It's not going to be accurate, completely accurate. But anyways, the magnetism of a material, including paramagnetic substances like oxygen, is not directly affected by elevation the way you described. I didn't think so. It has to do with pressure, temperature, and density. Sure. The magnetic properties of materials are primarily determined by their atomic and molecular structure rather than their location or elevation. And so that's what I'm saying. Their atomic and molecular structure impacts where it lands within this field of this cosmos. However, there are some secondary effects related to elevation and atmospheric pressure that might influence the overall magnetic response to the environment. Here's a more detailed explanation. Elevation and magnetic properties. Paramagnetism of oxygen. The paramagnetism of oxygen is due to the unpaired electrons in the O2 molecule. This intrinsic property does not change with elevation. Air density and oxygen concentration. At higher elevations, the air pressure decreases, leading to a lower density of air. We all know this. This means there are fewer oxygen molecules per unit volume compared to sea level. And by the way, we cannot function beyond 24 hours in a high oxygen environment, especially if it's 100% oxygen. It will lead to like organ failure and death ultimately after a 48 hour period. Yes, there are people that do the hyperbolic chambers for healing. This is a very limited in the time or the duration. That, yeah, it's all very interesting stuff. I just wanted to clarify that as well. To a lower density of air. This means there are fewer oxygen molecules per unit volume compared to sea level. I already said that. At lower elevations or below sea level, the air pressure is higher, obviously, leading to a higher density of air and more oxygen molecules per unit volume, because water also is H2O. And so I do believe this is some kind of like an electromagnetic reality that's being projected via the visible and non-visible light spectrum, but utilizing electricity and magnetism and the elements in order to perceive this reality. Anyway, it's really hard to explain. Impact on magnetic fields. Higher elevation. Since the density of air is lower at higher elevations, the overall concentration of paramagnetic oxygen molecules in a given volume of air is reduced. This can result in a slightly weaker paramagnetic response from the air. Lower elevation. Conversely, at lower elevations where air density is higher, there would be a greater concentration of oxygen molecules in the air, potentially leading to a slightly stronger paramagnetic response. Practical considerations. Effect magnitude. The changes in a magnetic response due to variations in air density with elevation are extremely small and are generally negligible for practical purposes. I don't really buy that. The intrinsic paramagnetism of oxygen is a weak effect to begin with. That I do agree with. And the changes in density do not produce a significant change in magnetic properties that would be noticeable without highly sensitive equipment. Other environmental factors such as temperature can also influence the magnetic properties of materials. For instance, increased temperature can reduce the alignment of magnetic moments in paramagnetic materials, slightly decreasing their magnetic susceptibility. And I've said this before, and so I do agree with that. And so that's why in colder climates or conditions, magnetism seems to function more effectively than electricity because of the flow or the yield that's required. And yeah, anyway, while there's a theoretical basis for a very slight change in the paramagnetic response of oxygen with changes in elevation due to variations in air density, the effect is minimal and not significant in most practical scenarios. Anyways, then why is there a Van Allen belt in the atmosphere and magnetism increased? So I asked that question. The Van Allen radiation belts are regions of charged particles, primarily electrons and protons. and I'm going to explain what protons are. But anyway, trapped by Earth's magnetic field. They are located in the Earth's magnetosphere rather than the atmosphere. Anyway, we have differing versions of reality there, and their existence is a result of the interaction between the solar wind and Earth's magnetic field. The Van Allen belts are important in the context of space, weather, and radiation protection for satellites and astronauts, but they are not directly related to the paramagnetic properties of gases in the atmosphere. I don't agree with that, obviously, at all, but I'm going to get into it, because again, this is what pseudoscientists are telling us, and they have been for many, many years. And so the Van Allen radiation belts, and it's just a radiation belt, and these are magnetic fields, electrical magnetic fields, with these particles that make it up, these elements, these gases, and in various states. So formation, the Van Allen belts are formed by charged particles from the solar wind that are captured by Earth's magnetic field. This is ChatGPT saying this. These particles spiral along magnetic field lines and are trapped in two main regions, the inner and outer Van Allen belts. So just talking about the location, which is also subject to interpretation. The inner belt contains high energy protons and electrons. So they are saying that the outer belt primarily contains high energy electrons. Magnetic field and elevation. The Earth's magnetic field is generated. Actually, I got to see if this is still playing. Anyway. Okay, it is good. The Earth's magnetic field is generated by the movement of molten iron and other metals in its outer core. That's not something I'd buy either. Creating a geomagnetic field that extends far into space. Technically, yes. The strength of the magnetic field varies with location and altitude, but does not directly cause an increase in magnetism with elevation in the atmosphere. That I don't agree with. Instead, the changes in magnetic field strength are more complex and influenced by several factors. Magnetic field strength. The Earth's magnetic field strength decreases with altitude as the distance from Earth's core increases. Near the Earth's surface, the magnetic field strength is relatively strong, but as you move further away from the magnetic sphere, the field weakens. And so this is another thing I believe as well. Like the further out we go, this is where we're experiencing like higher levels of magnetic fields, with this, which can also obviously be damaging to humans. But what also the environment, these electrical magnetic fields that are emitted from this electrical magnetic reality. And geomagnetic variations. The Earth's magnetic field is not uniform and varies with latitude, longitude, and altitude due to the shape of the Earth and variations in the core mantle or whatever. Anyway. So I asked, what is the composition of particles in the Van Allen belt? The Van Allen radiation belts consist of two main regions that contain different types of concentrations of high energy charged particles. The primary particles found in these belts are electrons and protons. So the radiation belt is literally composed of electrons and protons. But there are also other ions present. Anyway, this is different forms of matter. Here's a detailed breakdown of the composition. Protons. The inner belt contains a high concentration of high energy protons with energies up to several hundred mega electron volts. These protons are believed to originate from cosmic ray collisions from the Earth's atmosphere, resulting in secondary particles that become trapped. This is bullshit. That's a lie. But I'll get into that because I do ask about what protons are. And it's the absence of an electron in hydrogen. So protons are just positively charged or magnetically charged hydrogen, ladies and gentlemen. Anyway, and you can look it up, but I'm going to be explaining that as well. Electrons. There are also high energy electrons present in the inner belt, but in lower concentrations compared to protons. Electron energies in the inner belt can reach up to several, mega electron volts. Anyway, other ions. The inner belt contains heavier ions, such as helium and oxygen nuclei, which, though these are present in much smaller quantities compared to protons and electrons. Electrons. The outer belt is dominated by high energy electrons with energies typically ranging from tens of kilo electron volts to several mega electron volts. These electrons can pose significant radiation hazards to satellites and other space instruments. I'm just reading off ChatGPT right now, their explanation of this. Protons. There are also protons in the outer belt, but their concentration is much lower compared to the inner belt. Convenient. Anyway, proton energies in the outer belt are generally lower, typically up to a few tens of mega voltages, mega electron volts. mega electron volts. Similar to the inner belt, the other also contains small quantities of other ions, including helium and oxygen nuclei. Sources of particles. Yeah, I don't believe in this shit. So anyways, what elements make up the Van Allen belt? So I'm asking again. The Van Allen radiation belts are composed primarily of charged particles rather than neutral elements in their typical form. So they're charged radiation belt. These particles include electrons, protons, and a small amount of heavier ions. I might have already said this, but anyway, they didn't answer the question. Here's a detailed breakdown of the elements and particles present in the Van Allen belt. Because I'm saying, which is hydrogen. So the inner belt contains a high concentration of high energy protons. Protons are primarily hydrogen nuclei. Electrons. High energy electrons are also present, although in lower concentrations compared to protons. That makes sense in my version. Heavier ions, helium, He2, helium nuclei, alpha particles are present but in much smaller quantities. Oxygen ions are also found in small amounts. Other ions, trace amounts of other heavier ions like carbon, nitrogen, and iron can also be present, just like in the atmosphere, right? And so again, when you get to different temperatures, pressures, densities, pressures, and densities, pressures, and temperature, sorry, thank you. It's things become more electric or magnetic or neutral or in equilibrium. Outer Van Allen belt, electrons. The outer belt is dominated by high energy electrons. Protons, there are protons in the outer belt, but their concentration is much lower compared to the inner belt. So these are the heavier ions. Helium nuclei are present but in smaller quantities. So summary, the Van Allen belts are primarily composed of high energy protons, so hydrogen, and electrons. There are also small quantities of heavier ions, including helium, oxygen, and trace amounts of other elements like carbon, nitrogen, and iron, which are also paramagnetic and magnetic in nature. So these particles originate from the solar, and I don't believe in this, from the solar wind, cosmic rays, and geomagnetic storms trapped by the Earth's magnetic field. I do believe that they're like the spin is required, and the Zeeman effect discusses that. Anyway, the particles in the Van Allen belts are in an ionized state, meaning they are charged and not in their neutral elemental form. So then I ask, is a proton an element? Is an electron an element? I asked for the elements gases that comprise the radiation belt, so this just must be, so it must just be hydrogen and oxygen. Anyways, I'm just being a little bit of a troll here. That protons and electrons are subatomic particles and not elements. When discussing the composition of the Van Allen radiation belts in terms of elements, it is indeed more accurate to refer to the nuclei of elements, primarily hydrogen and helium and some heavier ions. So yes, I do. Like I was saying, that there's nitrogen, there's carbon, there's all these other trace elements or materials in the Van Allen belt, but it's largely comprised of things like hydrogen and in different states and oxygen, and this is just a fact. So while the Van Allen belts are composed of charged particles, these particles originate from atoms of various elements that have been ionized, stripped of their electrons. Here are the primary elements represented in the belts. So hydrogen, the most abundant element in the Van Allen belts is hydrogen, primarily in the form of protons, which are hydrogen nuclei. So that's very interesting. Helium nuclei, also known as alpha particles, are present in smaller quantities. So protons are hydrogen nuclei. I just want to reiterate that point, right? And helium, also known as alpha particles, are present in smaller quantities. And so when people are trying to explain away the elements and the gases and try to make it seem like it's not connected within this cosmos, it's a diversion and a distraction to make people not make that link, in my humble opinion. Oxygen ions are also present in the belts. These are heavier ions compared to hydrogen and helium. So whatever you want to call it. Anyways. I want to talk about atmospheric sputtering. Particles from the Earth's upper atmosphere can be ionized and trapped in the magnetic fields, adding to the population of heavier ions like oxygen. So summary, the elements that primarily contribute to the Van Allen's radiation belts in terms of their ionized forms are hydrogen, helium, and oxygen, mainly as protons, helium as helium nuclei, and oxygen in various ionized states. These elements are present in the form of their ionized nuclei rather than neutral gas forms due to the high energy environment in the belts. And this is why I'm saying, like, what people are trying to say, like the neutral gas molecules, sure, but there are different things you need to consider. Temperature, density, pressure, all need to be factored in because this impacts the elements differently. So I just wanted to further clarify ionized nuclei. When discussing the composition of the Van Allen radiation belt in terms of ionized nuclei, it is important to understand that the high energy environment strips atoms of their electrons, leaving positively charged nuclei. So when I'm talking about this being some kind of an electrical magnetic reality, and I talk about experiencing itself in a binary system, and there being like yin and yang, negative and positive, centripetal versus centrifugal, and such. This is very important. So primary ionized nuclei in the Van Allen belt. Protons, hydrogen nuclei, the most abundant particles in the Van. This is just more redundant. So the sources of ionized nuclei: solar wind, continuous flow charged particles from the sun, composed primarily of protons and alpha particles, ionized hydrogen and helium nuclei. So that's why I say that even with the sun and the moon, these luminaries, I do believe that there's a 7 original luminaries, wandering stars, whatever you want to call them. But I do believe that the sun and the moon have more of an impact on this cosmos and how it's projected, and the interactions of electricity and magnetism than any of the other ones. Again, that's just my personal opinion. And I do believe that the sun's solar rays are more of a radiating energy or force, and then the moon is more of a gravitational force. But I do believe that, like, even within these luminaries, utilizing sonoluminescence in order to be projected and work, I do believe that they do interact, like, also in a binary system. So again, like, even within like the luminaries, there's the capacity for generative and then degenerative effects in them, and positive electric effects, and positive and negative effects as well. So I just got to close down a memory that just came up on my feed. And I do believe that the gases and the elements, like, we need to look more into them and in the influence or the impact of magnetism or radiation, whatever you want to call it, because I do believe that radiation is derived from magnetism. And I do believe when we talk about the different forces in nature, when we discuss gravity, electrostatics, and these strong and weak nuclear forces, I do believe that it's literally just a breakdown of electricity and magnetism in different states, in different pressure systems, in different temperatures, different densities. And as the sun spins or travels around, causing these centrifugal forces, it like impacting the ether, like, this is why we get jet streams and things like that as well. I do believe that this is also something that's key, like that's creating this cosmos as well. It's facilitating it, or it's that movement of the luminaries is incredibly important to generate this cosmos and how we perceive it. I hope this makes sense. Again, this is really friggin' hard to explain when there's no friggin' frames of references and theories out there, just like not really. Anyway, if you want to divert me to people that can explain this better, I'm all ears. Ionized. Ionization refers to the process of adding or removing electrons from an atom or molecule, resulting in the formation of ions. An ion is an atom or molecule with an electric charge due to the loss or gain of one or more electrons. So this is why, like, looking at the periodic table and looking at the different states of each element within the periodic table is very important. Types of ions, I think you call them cations. These are positively charged ions formed by the loss of one or more electrons from an atom or molecule. So when I talk about negative and positively charged elements, or whatever you want to call it, this is more along the lines of what makes sense to me. And so even with hydrogen, when it loses its electron, it becomes positively charged. I don't know what we call it, positron. Anyway, proton, I know. Anyway, a hydrogen atom loses its single electron to become a proton, which is a cation. So this is an important one. A hydrogen atom loses its single electron to become a proton, which is a cation. Anions. These are negatively charged ions formed by the gain of one or more electrons. Example, a chlorine atom gains an electron to become chloride, which is an anion, which is used heavily in water. Ionization in the Van Allen belts. In the context of the Van Allen radiation belts, ionization involves the stripping away of electrons from atoms or molecules, resulting in positively charged ions. The high energy environment of the radiation belts leads to significant ionization, and this is what makes sense to me as well. Like the higher up you go, like heat rises and particles expand as you go up, and then they're more spread out and etc. But I believe that they become more magnetic, like the elements as they're stripped away of their electrons and things like that. And this is what I believe. What makes sense to me with how we have like these magnetic fields that, again, like that are all around us, and we also have our own magnetic fields, but obviously not as strong. Anyway, examples of ionized particles in the Van Allen belts: protons. The most abundant ion in the belts derived from ionized hydrogen. Helium ions form from ionized helium atoms. Oxygen ions results from the ionization of atmospheric oxygen molecules. Form from ionized oxygen atoms. Summary: ionization is a process of forming ions by adding or removing electrons from atoms or molecules. In the Van Allen radiation belts, this process results in the presence of various ionized nuclei, including protons, helium ions, and heavier ions like oxygen, which are found within this Earth plane cosmos, not in space, due to interactions with high energy particles from the solar winds and cosmic rays. So again, I'm going to say it's anyway, I'm asking this question: is there nitrogen in the Van Allen belt? Yes, nitrogen is present in the Van Allen radiation belts, but it is present in the form of ionized nitrogen nuclei rather than neutral nitrogen molecules. And so ionized nitrogen. In the Van Allen belts, nitrogen atoms can be ionized, losing one or more electrons to become positively charged nitrogen ions. These ions can be present due to interactions between high energy particles in the Earth's upper atmosphere. Source of nitrogen ions: atmospheric interaction. High energy particles from the solar wind or cosmic rays can ionize the components of the Earth's upper atmosphere, including nitrogen, which makes up 78% of Earth's atmosphere. So it contributes to the population of ions in the radiation belt. Cosmic rays that penetrate the atmosphere can also ionize atmospheric nitrogen, producing nitrogen ions that become trapped in it. Anyways, whatever. Cosmic rays, whatever. Unless you're talking about like the rays from the sun or the moon, I don't give a shit, to be honest with you. Okay, so the higher up we go in elevation, ionized gases such as helium, hydrogen, oxygen, and nitrogen lose their electrons and become positively charged particles that are paramagnetic. Again, this is a loose definition or a loose question. Ionization and elevation. As you move higher in the Earth's atmosphere, the density of atmospheric gases decreases. So yeah, and the likelihood of ionization due to high energy solar and cosmic radiation increases. So anyway, here's what happens. Ionization at higher altitudes. At higher altitudes where the atmosphere is less dense, high energy particles from solar and cosmic radiation can ionize atmospheric gases more readily. This ionization process results in the creation of positively charged ions. Example, hydrogen, helium, oxygen, nitrogen from neutral atoms and molecules. Types of ions, I already mentioned them. So hydrogen becomes protons. Helium becomes helium ions. And fun fact, NASA is like they must still be the largest consumers of helium in the world. And this is all for their satelloons and their satellites and there are other things that they use to search and well, research the ether and so many other things, and spy on us and bounce signals off, obviously, to emit internet connection. But it's still largely fiber optic cables underwater. Like 95 to 99% of the internet that we are receiving is from fiber optic underwater cables. Just to be clear on that. Magnetic properties of ions. Paramagnetism. Paramagnetism is a property of materials or ions that have unpaired electrons. These materials are attracted to an external magnetic field. Ionized gases or ions in the radiation belt, like protons, which is hydrogen removed of its one electron. Helium ions and other ions generally have unpaired electrons or specific magnetic moments. Therefore, they exhibit paramagnetic behavior. Effective elevation. The paramagnetic properties of these ions do not change significantly with altitude in a direct manner. Instead, the number and concentration of these ions can change due to variations in ionization rates and atmospheric density. What have I been saying? Anyway, in the ionosphere, a region of the atmosphere starting at about 30 miles, 48 kilometers above the surface. And by the way, the Kármán line is which is approximately 80 to 100 kilometers in elevation from us. This is what people see as the separation of inner versus outer space. And it could be the limits of this cosmos as well. But we can't go beyond that because of these radiation belts or these fields that we just physically cannot go past. Because of the limitations of our equipment, our devices, our technology, and our cells, and the limitations that are built within this cosmos. In the ionosphere, a region in the atmosphere starting from about 30 miles or 48 kilometers above the surface, increased ionization leads to a higher concentration of these paramagnetic ions. I'm going to reiterate that. Increased ionization, which means the removal of electrons, anyway, loosely explained, leads to a higher concentration of these paramagnetic ions. At higher elevations, the atmosphere becomes less dense and more susceptible to ionization. So I'm just going to leave it at that. At higher elevation, the atmosphere becomes less dense and more susceptible to ionization, so more susceptible to being more positively charged and more magnetic or paramagnetic, whatever you want to call it, and less electric. And I do believe this has to do with the interactions of these elements, these gases that make up this cosmos and that make us up as well. Ionization leads to the formation of positively charged ions such as hydrogen, helium, oxygen, and nitrogen. Paramagnetism. Many of these ionized particles are paramagnetic due to their unpaired electrons or specific magnetic properties. Thus, while the altitude affects the ionization and concentration of these ions, the inherent paramagnetic properties of these ions are due to their electronic structure rather than directly caused by altitude changes. So I don't agree with that at all. Or I really loosely, I don't agree with this. So protons are all ionized hydrogen. That was I just stated that. Yes, that's correct. Protons are indeed essentially ionized hydrogen atoms. Here's the breakdown of the concept. Protons and hydrogen. Hydrogen atom. A neutral hydrogen atom consists of one proton and one electron. The ionization of hydrogen. When a hydrogen atom loses its single electron, it becomes a positively charged ion known as a proton. In other words, a proton is simply the nucleus of a hydrogen atom without its electron. I hope this is clicking to people. I don't know. Characteristics of protons. Charge. A proton carries a positive electrical charge of +1 elementary charge. And so people try to spin this and correlate electricity with magnetism. And yes, this is like a unified. Yes, it's a unified force experiencing itself dualistically, but electricity and magnetism are separate and also the same, if that makes any sense. And the way they interact with each other is hugely important with how we generate energy. So even cameras and our eyes, like I've said, these are all profoundly impacted and projected via light, electricity, electrical and magnetic elements that are put into the structures of the camera itself. Within, there are electrical and magnetic properties at play, or interactions at play within, let's say, for example, a camera, and how we receive, or how it receives light from the environment in order to project images. Exactly how our eyeballs work, like a recording device or whatever you want to call it. In the radiation belts, protons are high energy particles that contribute to the overall radiation environment. Protons are indeed ionized hydrogen atoms. They result in the loss of the electron from a neutral hydrogen atom. In the Van Allen belts, protons are a major component of the inner radiation belt, highlighting their importance in space, weather, and radiation studies. Sure. Protons are magnetic. Yes, protons are magnetic. Here's how and why. Magnetic properties of protons. Magnetic moment. Protons have a property called the magnetic moment, which is a vector quantity that represents the strength and direction of their magnetic field. This magnetic moment arises from the proton's intrinsic spin and its charge distribution. So the spin, anyway, spin. Protons are spin half particles, which means they have an intrinsic angular momentum that contributes to their magnetic moment. Spin is a fundamental property of particles, and for protons, the spin generates a magnetic field. Just like the sun creates a magnetic field. Anyway, magnetic behavior. Due to their magnetic moments, protons can interact with external magnetic fields. This property is used in various applications such as nuclear magnetic resonance, NMR, and magnetic resonance imaging, MRIs. Proton and magnetic fields alignment. In the presence of an external magnetic field, protons align themselves along the direction of the field due to their magnetic moments. This alignment can be observed in experiments and is fundamental to techniques like MRI, where proton alignment and precession in a magnetic field are used to generate imaging signals. Energy levels. The interaction of protons with an external magnetic field leads to the splitting of energy levels, a phenomenon known as Zeeman splitting. This is utilized in spectroscopy and various other fields to study the properties of materials. Protons are indeed magnetic due to their magnetic moments, which arise from their intrinsic spin and charge. Applications. Their magnetic properties are harnessed in technologies like MRI and NMR, which exploit proton behavior and magnetic fields for imaging and analysis. Thus, protons as fundamental particles exhibit magnetic characteristics that play a significant role in both fundamental physics and practical technologies. So spin is a fundamental property of particles, and for protons, the spin generates a magnetic field. That was my comment I wanted to further expand on. Yes, that's correct. Spin is a fundamental property of particles, and it plays a crucial role in generating magnetic fields. Here's a more detailed explanation of spin and its relation to the magnetic properties of protons. Spin and magnetic field. Spin. Definition. Spin is a form of intrinsic angular momentum possessed by elementary particles such as protons, electrons, and neutrons. Unlike orbital angular momentum, spin does not arise from the particle's movement through space, but its inherent property. Sort of. I don't entirely agree with that. Because it's spin does not arise from the particle's movement through space, but its inherent property. But it's literally the spin that creates the inherent properties of magnetism. So even like saying light in motion, like that's being redundant because light is like the particles or whatever you want to call it that make up light. They're in constant motion. Magnetic moment. So origin, the spin of a proton gives rise to its magnetic moment, which is a vector quantity representing the strength and direction of the magnetic field associated with the proton. Relation. The magnetic moment of a proton is directly related to its spin and given by this formula, where this Y-looking symbol, anyway, is the gyromagnetic ratio, a constant specific to the proton. Magnetic interaction. Alignment. In the presence of an external magnetic field, protons align themselves according to their magnetic moments. This alignment can cause the protons to experience forces and torques due to the external magnetic field. And so this is where they talk about the Zeeman effect. The splitting of energy levels of protons in a magnetic field, known as the Zeeman effect, occurs because of the interaction between the proton's magnetic moment and the external field. Applications of proton spin and magnetic moment. Nuclear magnetic resonance, NMR, relies on the interaction of nuclear spins, such as protons, with an external magnetic field. The alignment and precession of spins in the magnetic field produce detectable signals, which are used to probe the structures and dynamics of molecules. Magnetic resonance imaging principle. MRI uses the magnetic moments of protons in the body, typically in water molecules, to generate images. The alignment and relaxation of proton spins in response to radio frequency pulses in a magnetic field create the imaging signals. Spintronics. Emerging field. Spintronics is a field of technology that exploits the spin property of electrons, and by extension protons, for applications in electronics, potentially enhancing the performance of devices and creating new types of memory and logic devices. Spin is a fundamental quantum property of particles like protons, contributing to their intrinsic angular momentum. Magnetic field. The spin of protons generates a magnetic field, giving rise to the proton's magnetic moment. The interaction of proton spins with magnetic fields is utilized in NMR, MRI, and emerging technologies like spintronics. Understanding proton spin and its magnetic properties is essential for various scientific and medical applications, as well as for advancing technologies. I could not agree with that more, and I do believe that the sun and the moon need to be further investigated for their magnetic electrical interactions and components and properties, and the way they generate and radiate their force, their forces. It's really, really hard to explain. But anyway, I'm gonna put on a video that I haven't seen yet about the Zeeman effect and see what that is all about.
Platform. Add products.
No. I'm gonna skip.
In this video, we will discuss the Zeeman effect, which describes the splitting of spectral lines under the influence of an external magnetic field. Historically, we distinguish the normal Zeeman effect, where we do not have spin, and the anomalous Zeeman effect, where we do consider spin. The reason why it's called anomalous Zeeman effect is that the concept of spin was discovered more than 20 years after Zeeman did his experiments. At that time, he could not explain the results he was getting, so it was called anomalous. Whether we consider spin or not, the Zeeman effect is based on the interaction of a magnetic moment with an external magnetic field. In particular, the potential energy of this magnetic moment is given by the negative vector dot product of magnetic moment and magnetic field. This magnetic moment can be written in terms of a g-factor, a magneton, and an angular momentum. This magneton depends on the charge and the mass.
It's just particles, elements, whatever you want to call it, like in their various states, they're seeking equilibrium, just like we do, and so I do believe that we need to look more into the interactions of electricity and magnetism within different temperature, pressure, and density states, much more. Because I don't believe, because I believe that even with these particles that we see like heat rises, I believe this absolutely has to do with the paramagnetic forces that are at play in order to make them try to equalize within their environment. And so the more magnetic, possibly. Anyway, I'm gonna stop talking because this is all friggin' difficult to explain. But yeah.
Mass for the specific particle. In case of an electron, this is the Bohr magneton. If we now, for example, consider orbital angular momentum and spin, the magnetic moment would look like this. Moreover, if we consider a specific particle like the electron, we can use electron-specific values for GL.
So there are comments on Rumble. So water is H2O. I mean, there's obviously other elements and gases that are in it, and so for example, salt water, it interacts more. It's more electrically conductive than fresh water or water that doesn't have like the salt and the seaweed, stuff like that in it. So ocean water generates more of an electrical force or current than fresh water or clear water. And so I've said this before as well, like water is H2O. These are gases. So even within the atmosphere, it's still H2O, hydrogen, oxygen, helium, nitrogen, carbon, etc. And so this is what I'm saying, that we need to fundamentally break down and reassess the periodic table, and including the gases especially, and then look at the interactions within, again, different pressure systems, different densities, different pressure systems, and different temperatures. And so even water, there's various states of water, right? You've got the liquid, solid, gas, and I believe to be plasma, and all have different capacities of generating or expelling these forces like electricity and magnetism based on all of these factors. And so the atmosphere is comprised of the elements, and so is water. And so I just wanted to clarify that.
NGS, as well as the Bohr magneton. What all of this tells us is that the energy levels of an electron, for instance inside a hydrogen atom, change under the influence of an external magnetic field. Now that we have set up all necessary equations, let's talk about the Zeeman effect for an external B field in the Z direction. First, the normal Zeeman effect. Here, we only consider orbital angular momentum. An example could be an electron in a spin singlet state, such that its spin quantum number is 0. If we calculate the energy shift due to a magnetic field, not forgetting about the electron's negative charge, we get to the result mu b times ml times bz. Since different values of ml are integer steps apart, the line splits in equally distant lines. For an electron with L equals 1, we get 3 lines. Also, if we increase the magnetic field, the lines will move further and further apart. Next, the anomalous Zeeman effect. Now we have orbital angular momentum as well as spin, which together couple to a total spin j. By doing the same calculations as before, we get the result that the energy shift is given by E over 2m times Lz plus GSSZ times the magnetic field. Here we notice that the magnetic moment is no longer parallel to the total spin j, since GS is approximately 2. However, Lz and Sz are anyway meaningless when we are dealing with a total spin j, so we have to rewrite it somehow. After some steps which are out of the scope of this video, we can write this also as mu b gj times bz, where this gj is a special case of a g-factor called the Landé g-factor. This is not a constant, rather it depends on L, S, and j. Therefore, the line splitting is not equally separated as with the normal Zeeman effect. For example, for electrons in the p1/2 and p3/2 states, the lines will split like this, where the splitting for the p1/2 state is larger than for the p3/2 state. Again, the reason for this is that the Landé g-factor is different for the p1/2 and the p3/2 states. Finally, let us talk about the Paschen-Buck effect. This is a special case of the anomalous Zeeman effect, where the magnetic field gets so strong that L and S decouple again and interact independently with the magnetic field. Therefore, we can use the result that we dismissed earlier, containing Lz and Sz. After replacing the operators with their eigenvalues, we get mu b times ml plus GSMS times the magnetic field. Note here that since GS is approximately 2, even though spin takes on half integer values, it looks like an integer contribution. To illustrate this, let's take the p1/2 and p3/2 states again. The letter P tells us that they are in fact L equals 1 states. After doing some calculations, we get 5 new energy levels, corresponding to those values of ml, ms, and ml plus 2ms. Since those lines have equal distances from each other, it looks like as if by increasing the magnetic field strength, we can go from the anomalous Zeeman effect to a normal Zeeman effect. But that's pretty much it for this video. Thanks for watching.
Okay, so there's still so much I want to ask, but okay, so I can explain how it becomes. I just want to see what ChatGPT says. So I'll stop sharing. I'll go back on ChatGPT just to show you again what I'm asking and what they're coming up with. Okay, so helium's magnetic properties. Normal helium, helium-4. Non-magnetic helium is a stable non-magnetic gas under normal conditions. It has no permanent magnetic moment because its electrons are paired and its atomic nuclei have no net magnetic moment. Helium-3 and magnetic properties. Helium-3, this isotope of helium has a different behavior compared to helium-4. Helium-3 has nuclear spin, which can give rise to magnetic properties in specific conditions. However, this is not about the absence of electrons, but rather the intrinsic properties of the helium-3 nuclei. I'm saying that's incorrect. I'm saying with the absence of electrons, this increases the magnetism of elements. And that really hurt by doing that, but it's okay. And so even with hydrogen as my example, sorry, with helium as my example, I want to see what ChatGPT says, because again, this is not a good reputable source, but it has been useful for just general information to explain things that are possibly properly explained. But anyways, this is not so. Superfluid helium, superfluid phase. At very low temperatures, helium-4 can become a superfluid. In this phase, helium-4 does not exhibit magnetization in the traditional sense, but it displays unusual quantum effects and behaviors due to its quantum mechanical properties. Helium in strong magnetic fields. Quantum effects. When subjected to very strong magnetic fields, helium atoms may show slight magnetic effects due to quantum mechanical interactions. I'm saying that it's higher up in the atmosphere, most abundant because it has like one electron, one proton. When you remove the electron, it's just a proton, and this is like this is magnetic, right? So anyway, and so they want to talk about this being quantum physics and stuff like that. Sure, like whatever. Absence of electrons and magnetism. Absence of electrons. If an atom loses electrons, becomes ionized, it does not typically exhibit magnetism in the absence of electrons. For instance, ionized helium would be a nucleus without electrons, and it does not become magnetized in the same way as materials with unpaired electrons do. So again, they're just trying to explain it away. They're just saying it doesn't become magnetized in the same way as materials with unpaired electrons do. Diamagnetism. This keeps on coming up. All materials, including helium, exhibit diamagnetism to some extent. Diamagnetism is a weak form of magnetism where materials create an induced magnetic field in opposition to an external magnetic field. Helium exhibits this weak diamagnetism, but is not the result of the absence of electrons. So I just already said this, but or showed this in a previous thing that ChatGPT said, but I'm going to re-ask it. Okay, so they're already saying that they're okay. So it's helium. Again, I already asked this. I already said anyway. That might be a strange question to ask because I get where they're going from. They're saying anyway. Am I saying it wrong? I don't want to say magnetic. Or sorry, paramagnetic. Maybe paramagnetic is the wrong term to do because that's just that's not. Yeah. Let's go up to the top again. Diamagnetic, yeah. And then oxygen is paramagnetic. So yes, oxygen, and I already asked that again after that, but saying that it is, it's indeed paramagnetic. So like, what is it? But again, this has to do with oxygen and its different pressure, temperatures, pressures, and densities, right? So this is like all the other gases as well. So they're not going to come right out and say that at ChatGPT because there's no frame of reference for helium, hydrogen, and oxygen being other than what they try to say is diamagnetic, or anyway, because people are trying to say that there's no that magnetism is not a force. It's the absence of a force, and I don't agree with that at all. And this is why I'm trying to get into this research, because there are like magnets. There are strong forces at play, right? When you play with magnets, right? They don't repel each other. They actually can attract each other based on like the positive and negatively charged magnets, whatever you want to call it. It's hard to explain. And so even magnets can lift up like large vehicles, like large infrastructure, and because of that attracting force, right? And anyways, there's more to it as well, but I don't want to belabor things that I've already asked before I fully understand it. And so summary, proton. So a proton has a magnetic moment due to its intrinsic spin and can interact with external magnetic fields. It's not paramagnetic in the traditional sense of the term. So again, like this is all based on like, oh, it is, but if you think about it this way, then no. This is how we're going to explain it away. So in summary, while protons exhibit magnetic properties due to their spin, they're not classified as paramagnetic in the usual sense associated with unpaired electrons. It's only because it doesn't have a fucking electron. Like, so this is what I mean. Like, use your words and don't add things in just to make it seem like it's not what it is, because this is what's really fucking confusing people. Like even the greats like Walter Russell, right? And Searle, like the SEG, the Searle effect generator. And so many other devices out there now are showing that like we really need to look more at harnessing magnetic energy or force, whatever you want to call it, and because it could possibly be more efficient than what we're currently utilizing with electricity. And electricity does generate a lot of heat as well, and that's why when we were talking yesterday during the VIP show. The climate change or whatever you want to call it, like there is an element of humans further exacerbating the like these climate conditions that we're experiencing, but this is man-made by a very select few of us that are ruining it for the rest of us, right? With this overdevelopment, with like CERN and HARP and like all these EMP, EMF technologies that are being tested and experimented on like all over the friggin' world. This is causing a lot of damage, and within this contained environment, so it's not getting released into the atmosphere, then away from us, right? And so we're seeing that too, like with the contrails and the chemtrails and stuff like that as well. And yeah, anyway, so this was just like a snippet. Oh my god, I'm over an hour in. I thought this was like half an hour in. I'm like, it's not gonna be a long video, just on magnetism. I have shared stuff that Ken Wheeler has shared on videos. He has shown magnetic fields. Like not only like within the atmosphere or the environment, but also like he has frozen a magnet in water, and you can see the fields that are created as well. It's obviously a weaker field, but it's also friggin' interesting to me. And so, yeah, I'm just saying that this, I'm by no means an expert in this. I definitely need to do a lot more research into this, but I think that I'm closer than a few people, and I would love to pick the brains of people like Jaron and Ken Wheeler for in Austin, and get their explanations of this, because it's a lot. It's a lot. And I think we really need to look more into it. So anyways, on that note, I will leave it at that, and I hope that everyone has a wonderful rest of your day.